just want to clear up a little misnomer, if you will. This is probably one of the things that is right on this board. So, although they have it labeled positive and negative, they have to discern the commons from the inputs and or outputs in this case. So I would consider this positive an output and this negative an input. And for any of you guys out there that are messing with Arduinos and stuff like that, you've probably heard of GPIO, and that's what these are, just general purpose in and out. Now, because this is specific for this particular board, you probably wouldn't call it a general purpose in and out. But each one of these, although there may be some circuitry that comes in to this, each one of these is tied into one of these circuits right here. So these are ins and outs, probably just one common point and then a bunch of inputs. But either way, these on other boards, or you will find them labeled normally open or common or normally closed. However, in these inputs, when it has to do with photo eyes and exits and other inputs of that nature, they are not relays, and that's where it can kind of get confusing. If you look at this and think of this as a general purpose in and out, again, using the Arduino terms, but if you look at these as inputs or outputs, that's actually what they are. Now, that doesn't mean that there's no relays built on this. This has a relay which is tied directly into the magnetic lock, because you're handling current through a dry contact, and there's two different terms that we would use in this scenario, a wet contact and a dry contact. And these have voltage on them, and this only has voltage on one side of it, the solenoid side. And you can see some input protection there and things of that nature, because what it's going to hook up to is a solenoid door strike or another type of coil, a maglock. And those, when they are powered, they will run higher voltage or higher current sometimes than what these inputs can handle. And those, again, are going back over to this CPU, which can only handle a certain voltage and a certain current. So in a maglock, we have the ability to run low voltage through this to control the solenoid side, and then isolated from that is the contacts. And you can see what kind of ratings on there and voltage and amperage. It looks like 1 amp at 250 volts or 10 amp at 150 volts. Either way, more than we're ever going to actually put through this. But the problem with that is because we have a wet contact, meaning it has voltage on it, you could trick one of these if you supply it with voltage on top of not being able to handle the amount of voltage and current that's going to go through it for a solenoid or a maglock. And a solenoid and a maglock, although these have some input protection, you are going to use external input protection as well too. And again, a misnomer, input protection, well, input, output, but it's protecting the circuit from high voltages. And what happens is when you have a coil on a circuit, and the energy from it is immediately shut off, well, the magnetic field, which is what happens when you energize a circuit, you create an electromagnetic field. And in this case, we're creating an electromagnetic field to be able to hold and concentrate power. So in a solenoid, we want to pull a plunger down or push it up. And in a maglock, we want to create a coil and a strong magnetic field so it'll attach itself to the armature plate. But here you see normally open, common, and normally closed. And you can see that on another circuit board that is showing normally open, common, and normally closed, but it is actually not attached to a relay where this input is. Here it says NO, normally open, COM, common, and NC, normally closed. And depending upon what device you're hooking up to it or how it's set, whether it's fail-safe or fail-secure, is going to determine how you connect it. So going back to when we de-energize a device such as a coil that is holding on to, in this case, the characteristic of a circuit would be voltage. Coils are voltage holders, inductors are current holders. And you have normally open, common, normally closed. That's the point of this video, is to show you that when you have circuit boards that are labeled directly through the ins and outs of the CPU, they may or may not be relays. Well, if it's hooked up to the CPU, it's not. If it's going directly to that, it's not a relay. And sometimes you will have them labeled normally open, normally closed, and common, but just keep in mind, calling that a relay is not accurate. It's actually just an input, or depending upon how you look at it, input output. So you can just call it IO. Down here is a different story, because we have the same thing happening on one side of this circuit being attached to a low voltage side. And let's see what the input voltage is. Let's see if it says what the coil is. So there's a circuit. You could probably figure out what the coil is. That's the device that is closed on the energized side to actually open or close on the dry side, meaning the one that has no power. That way you can run power through it without affecting the device. So just keep in mind, these are IOs and this is a relay regardless of how it's named. You could have normally open, common, and normally closed on these IOs that go to the CPU, but they are not necessarily relays. They're just ins and outs, and this is the actual relay. Now, you have other relays over here, too, that are handling high current, but this particular one, those are going to the motors, and these are going to an external device, most likely to lock the gate closed. But you can see some input protection here. On a, depending upon the type of current that you're using, whether it's alternating or direct, or really direct current is kind of stupid. It needs to be called constant current. And that's what other languages outside of English call it constant current. And that's really what it should be, meaning that it doesn't fluctuate, it doesn't change polarity under normal operation. It stays at or above 0 volts, and that would be direct current. So, but you will have, depending upon the current type, you will have external protection that comes with it. And that will be in, typically, most manufacturers will include a metal oxide varistor, or what's called a MOV, or it will carry a diode, and or they'll send you with a couple of diodes, a couple of MOVs. A diode is more of a gate, so it allows, it's kind of like a valve, it allows electricity flow in one direction. Now, there is some voltage that's lost through it due to heat, and there is a little bit of voltage that can still seek back the other way, and there are some diodes that actually, by nature, will allow electricity to go back and forth until a certain voltage is gone above or below. I'm not an expert at those. Well, I'm not really an expert in any of this stuff. I've just read one chapter ahead of the book than you have. But I'm not an expert at those. But the diodes that we use in this case are for input protection. Sorry, I'm shaking my knee. That's why the camera's going like that. But are used for input protection, so they allow the electricity when the a magnetic field collapses, it prevents it from going back through the coil and contacting that, and possibly the board, not through the coil, but back through the electronics. Because in the case of whether it's AC or DC or a maglock or a door strike, it can send hundreds of volts, which is common, but sometimes up and above over 1,000 volts when that coil, or excuse me, that electromagnetic field collapses. So that's why the external input protection. And on a solenoid, like I said, you will have a diode sometimes, and it acts like a gate. And on a mag lock, sometimes you will have a metal oxide varistor. Metal oxide is the material that it's made out of, and varistor is, like all of electronics, explaining what it is. It's a variable resistor, very variable and resistor. So anytime that you hear those types of words, it gives you an idea of what it's actually doing, such as transistor. So trans is taking the voltage up or down. It's transforming the voltage, and that's where a transformer comes from. So transistor is a resistor in essence, although you wouldn't necessarily look at it like that, but it is transforming voltage by keeping three contacts close together, and then one of the low voltage contacts passes current through there, then that completes the circuit. For the high voltage, blah, 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 metal oxide varistor material, and then it's a variable resistor. So it only starts to resist at a certain point, which is when the material inside breaks down and prevents electricity from flowing. Now, it's not a breakdown as it's a one-time deal because metal oxide varistors, or MOVs, what they're short for, can be used over and over to absorb high voltage and electricity. But and it also, those depend on where you place them. Diodes, you're going to do it at the device most of the time, and metal oxide varistor, you're going to do it back here at the circuit board. If I'm not going too fast and thinking about it off the top of my head. But either way, that's what the manual's for, and explains it pretty clear. I wonder if it's actually in the wiring diagram for this. Nope, I don't see it in here. What does it say? Optional, not provided, optional, not provided. So in the wiring diagram, it shows solenoid lock and mag lock, but it doesn't show the optional protection pieces in there, at least on that page. Solar transformer reset. So unfortunately, this board was designed pretty poorly, not by a gate technician, but more likely a garage technician who's never serviced a gate operator. So in order to see what this actually is, guess what you have to do? You have to spend that time to pull it off. So which is very inconvenient and doesn't make sense, because in order to do that, you have to figure out the wiring. You have to pull that off on a lot of these. Whereas if it was labeled somewhere other than underneath the device, you could actually see what it is. And it only gets magnified when you start to pull stuff like this in there. So anyways, I just wanted to bring that, make that point that even though something's labeled normally open, common, and normally closed, doesn't necessarily mean that it's a relay. And that's kind of what the distinction is between the two. A relay on a circuit board will typically look something like this or like that. And this is an isolated circuit, meaning that it doesn't have electricity flowing through the part that goes here, but the coil has electricity that comes from the power supply and the CPU to actually close that circuit and then open or close the circuit over here, depending upon what's hooked up to it. And these are general purpose IOs, or in this case, because it's specific, it is an input output. And those go directly over to the CPU, and most likely through the input protection over here to one of these little silver connectors. And when it gets voltage and stops receiving voltage, it tells the software in here to do something. So if it gets voltage from the exit device, comes over here, it says execute this line of code. Oh, by the way, if this is happening, do this, and if this is not happening, do this. So there's several lines of logic in there, and that's what you need in some of these cases. For instance, if you get a, let's say, a fire department command, and that is circuit is closed, and it's got that stuck in the memory that the circuit is closed here in the software, then it's actually going to override the single button control. I think that's what SBC is when you give it a closed command, or at least I hope that it would. But anyways, this is a popular control board for LA400, as you can tell. Not designed very well, but it's when you have it designed by garage door technicians, you're not going to have a board or somebody that's an engineer that doesn't service these every day. They've done some really cool things with this board. The MyQ technology, or excuse me, the receivers in these things are one of the best, and they do a really good job. And the 850LM receiver is definitely one of the best. It's one of the ones that I use. But as far as designing a control board, it's not that user friendly. It does the part, but coming from the technology that they've purchased from other companies to this, it's definitely disappointing. But that's coming from an installer standpoint. From a production standpoint and a manufacturing standpoint, this could be the best thing since sliced bread. Low cost, easy to produce, nothing super complicated, and that's it. So IOs, relays, relays. Inputs and outputs, relays, relays.